Welcome to solverfy.
Okay, so for problem 12, we're looking at the distributive property, and for part A, we want to take A plus B and multiply it by C. Okay, so this is going to look like in matrix form. We would have A plus B being A11 plus B11 all the way to our AMK plus BMK. And then we multiply that by our C matrix, and our C matrix being K by N. Okay, and so when we take for example, our first row by the first column, so this would be in our product matrix, only the element in the first row, first column, that element is gonna look like this. So we're gonna have A11 plus B11 times C11. I'm gonna add that to A12 plus B12 multiplied by C21. And we're going to add that. And we're going to go all the way down to A1K plus B1K multiplied by CK1. And you can, of course, do this, write it more generally with notation, index notation, but the indexes are confusing enough in the discrete case, so I'm hoping this will be more illuminating. But in this one element, this first row, first column element, these values, we can use the distribution property, right? These are just regular old numbers, and we know that that works, okay? So this is going to be equivalent to A11 C11 plus B11 C11 all the way down to A1K CK1 plus B1K CK1. Okay, and then we can sort of separate these, right? So we could take all of our elements with A, so A11, C11 all the way down to the A1K, CK1, and add that to all of the elements with B, B11, C11, all the way across to the B1K, CK1. Okay, well this then is actually going to be the same as taking the product of A and C. And the second section is going to be the same as taking the product of B and C. Of course, what I've written here is just taking the one row and column, row of A and the column of C, but if you repeat that for all the columns and rows, that's what you'll get. And so then we can see that this A plus B times C is actually equivalent to A C plus B C. All right, then if we go on to part B, which is a similar concept. This time we're taking the product of C multiplied by A plus B. All right, but the process is basically the same. We just had to change some of the sizes to make that product defined. Okay, so again, we get our matrix where the element in the first row and first column is going to look like C11 multiplied by A11 plus B11 all the way to C1K multiplied by A K1 plus BK1. Okay, and this, again, what I've written there is just the first row, first element, okay? But if we take this expression, and again, use the distributive property, we can write it out as C11A11 plus C11B11 all the way down to C1K AK1 plus C1K BK1. And then we can corral them, right? The way that addition works is we can change their order any way we want. So we can have it as C11A11 all the way to the C1K AK1. And we can add that to all the elements with B. So we get C11B11 all the way to the C1K BK1. And I apologize for having to put that below there. I ran out of room. Okay, and with this is the same as the product of C times A, or it's the first row of C multiplied by the first column of A. And this is the first row of C multiplied by the first column of B, right? And so generally, if we were to sort of repeat that for all the elements, it would be the same as the product of C and A plus the product of C and B. Okay, so then we can see that C, the product of C with A plus B is the same as the product of C plus the product of